Hi guys, we are moving on to a new topic which is trigonometry, something we've seen before, but we are now looking at trigonometric graphs. Before I get going talking through this page of the notes, you do need a calculator for working out some of the questions in these notes, so please, if you don't have one, make sure you go and get one just now. The three trigonometric functions, sine, cosine and tan. We've already seen these before last year. Basically the whole topic is just working with angles and sidelines in right angle triangles, and we get these three ratios. We get the sine of the angle theta as the opposite over hypotenuse, the cosine of the angle theta is the adjacent side over the hypotenuse, and the tangent of theta is the opposite over the adjacent. And these three ratios can be conveniently remembered by the little SOHCAHTOA kind of memory tool, and that's a trigonometric ratio. So we're not so much going to be looking at the ratios in this topic, and we're going to be focusing on the actual trigonometric functions themselves, sine, cosine and tangent, and what they basically look like when you graph them, when you draw the graph of them. Okay, now these are formed still using the relationship between the angles and sides in a right angle triangle, but it's when it's drawn within what's called a unit circle. And because of this, the graphs, we tend to look at the graphs between the angles of 0 and 360, as it says at the bottom here. And that's because of this relationship within a unit circle. I've actually posted a proof of this on to our Teams page, where you can see how a right angle triangle is drawn within a circle and how that affects the sine and cosine ratio. Go and have a look if you're interested in your own time, but you don't really need to know it. All we need to know is that the three graphs we are dealing with are the graphs of y equals sine x, y equals cosine x, and y equals tan x. And what we're going to do initially is actually draw these three graphs to get an idea of the shape of them and the various features and what they kind of look like. So, as I say, we need a calculator for this. Make sure you have your calculator ready. What we're trying to do here is, what is the value of sine of x when x is at these various angles? So these tend to be the sort of reference points whenever we're drawing a trig graph at National 5 level, as we have 0, which is right at the very beginning here, and 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And you'll notice, you can hopefully see the connection between that and a circle. That's like a quarter turn within a circle, and that's going to be our kind of reference points for drawing this first graph, which is sine x. So all I want you to do is to find the sine function on your calculator, which you should see there's a button, three buttons in probably side by side that says sine, cosine and tan, or sin, cos and tan, but it's sine the way you pronounce it. So all we're going to do is hit the sine button, hit 0 and hit equals, and it should give you that the answer is in fact 0. Now that means that when x is 0, the graph starts at a y coordinate of 0. So it actually starts right on the sort of kind of origin there. That's where the sine graph starts. Okay, we're just going to repeat that for the rest of the angles. So sine of 90, that gives me an answer of 1. So when x is 90, the graph is up here at 1. So draw a little dot just there. Sine of 180 degrees, that's going to be 0. So that means when x is 180, the graph comes back down to 0 on the x-axis. So draw a dot there. Sine of 270 is minus 1. So when x is 270, the graph comes down to minus 1. And then lastly, sine of 360. And you should get an answer of 0 again. So when x is 360, all the way along at the end here, the graph comes down to back to the x-axis. So the key here is that if we put in every single angle between 0 and 360, we would be able to get a more detailed shape of the graph. But know that we do not connect these with straight lines, so it doesn't have like kind of right angles here. This actually forms what we call a wave. It forms a kind of curve that looks like a wave. So when we're actually drawing this, we're going to start at 0, we're going to go up, and it's going to basically kind of like a parabola. It's going to have its maximum at 1 and then start making its way back down to 180. It's going to come down and then it's going to curve at -1 and come back up to 180. So it should be a bit of a kind of wave and sort of look a bit like an S. That is your graph of y equals sine x. Okay, we're going to move on to the cosine graph. Again, it's similar. It's a kind of wave, and we're going to use the same reference points, the same angles for x, 0, 90, 180, 270, and 360. So you can start to fill that in yourself. So the cosine of 0, so this time it doesn't start at 0, it actually starts at 1. So when x is 0, the graph actually starts up here at 1. Cosine of 90 is 0. So when x is 90, the graph comes back down to 0. The x-axis. Cosine of 180 is -1. So when x is 180, the graph is down here at -1 in the y-axis. Cosine of 270 is back to 0, so you can kind of see the shape of the sort of curve kind of forming already. And cosine of 360, it's back up to 1. So this graph actually finishes kind of the same place it starts, just like the last graph, up at 1 this time. So again, when we're drawing this, kind of treat it as if this was the top of a kind of maximum turning point. So we're going to kind of come and curve down to 90, all the way down to 180, curve back up the way, and then curve to the finish line there. And you know, the sine graph you hopefully see looks a bit like an S. The cosine graph looks a bit like a C. So that's how you remember which one of those is which. Now that's the two main graphs we're going to deal with in trig graphs. There is the third one, the trig graph. Now this the tangent graph. The tangent graph works completely different and is very very different to these two. And as you'll see in a second, it's quite difficult to actually draw or find values for. So we don't deal with it as much, but we do need to have an understanding of what it looks like. So we'll do that now. So right, last one. I'll do this in green. So when x is 0, what is the value of tan x? We'll put in tan of 0 and it starts at 0, 0. Okay, that's fine. So put your dot there at 0, 0. Now put in tan of 90 and you should be getting error. Now that's not a mistake. The tangent graph actually never connects with the line x equals 90. So it's a little bit funny. I'll show you what happens. What you're going to do is you're going to draw a dotted line, vertical dotted line. Actually, I'll do that in black. You draw a vertical dotted line, please, right down through 90. Now that is called an asymptote. Now an asymptote is a line that, or a value that our graph never ever gets to. It never ever touches that graph. What this graph actually does is it starts at 0, 0. It kind of curves up the way and then it starts going up exponentially to the point all the way up to positive infinity, but it never actually crosses this line. It never actually gets to x equals 90. It doesn't have a value because that's just going up to positive infinity. Told you this one was a wee bit different. So just put in NA for 90. Okay, if you put tan of 180, again we get 0. So at 180 we know the graph comes back to 0 at some way or other. Tan of 270, we get another error. So put in NA. We'll deal with that in a second. That's going to form another one of these asymptotes. And the tan of 360 is actually back to 0. So we need another asymptote at 270. So draw another dotted line going right through to 70 degrees. And here's what the tangent graph looks like. It starts at 0, goes all the way up to positive infinity, but never actually gets to 90, but then it comes back from negative infinity just over 90 degrees. So just past your dotted line, it actually comes up from negative infinity, comes back to 0, and then repeats what it did at the very beginning. Curves all the way up to positive infinity, never touches the asymptote, and then just after 270 it repeats what it did just after 90. So it comes up from negative infinity and then finishes there. So that's the graph of y equals tan x. Completely different, very difficult to work with because there's impossible values, there's infinity, negative infinity, so we don't often work with the tan graph at all, but we do need to know what it looks like. Okay, so we're going to move on to the next page. That's just an understanding of what the graphs look like. Now we're going to look specifically at the equations of the graph and how they kind of relate to the equation of the function, and how they relate to the graph. Okay, so there's two main parts of the equation. We've got the amplitude and we've got the period. Okay, so first of all, the amplitude is basically just a way to describe the vertical height of the graph, right? And we define it, and this is important, as half the distance between the maximum and minimum values. Can you highlight that or make that, highlight that or something like that, because that is really, really important. The amplitude is half of the distance between the maximum and minimum values of the graph. So if you have a glance back at your sine graph, you'll see that when we're talking about amplitude, we're talking about the height, the vertical values, so the y-axis. So the maximum is 1, the minimum is down here at -1. So it's literally just half of the distance between 1 and -1. That's what the amplitude of that graph is. Okay, so it kind of says that in this little example here. So the maximum value is 1, the minimum value is -1, so the amplitude is just half of that distance. The distance is 2 between 1 and -1, so therefore the amplitude is 1. So in the graph of y equals sine x, 1 sine x, the amplitude is just 1, so can you just mark that in? And it's going to be the same for the cosine graph. If you look back at your cosine graph, you'll see it starts at its maximum and it finishes at its maximum of 1. It goes down to -1. Again, that's a distance of 2, so the amplitude is 1. The period of these, we'll deal with sine and cosine first, then we'll talk about tan. The period is how many degrees it takes for the graph to complete one full cycle, or one full wave, as we often refer it to. Okay, so you find this by dividing 360 degrees by the number of times the graph appears within that range of 0 to 360 degrees. So if we look at, again, we glance back to our sine graph as an example. One full cycle is starting at 0, going up to a maximum, coming down to a minimum, and returning to where we started. That's one full wave, and that happens in 360 degrees. So the period of y equals sine x is just exactly as you see it, 360 degrees. And as it says there, it's got the wee example, 360 degrees divided by the one time that we see it within that range, so the period is 360 degrees. Cosine graph, exactly the same. It starts at the maximum, goes down to the minimum, back to the maximum. That's one full cycle, and that happens once in 360 degrees. Now the tangent graph, a bit different because we cannot define the maximum or minimum value. The maximum is positive infinity, the minimum being negative infinity. It's impossible for us to do a calculation to get an amplitude, so there is no amplitude for the tan graph. The period, however, we can get a value for that. So how many degrees does it take to repeat itself? Now sine and cosine was one wave in 360, but if you look at the tangent graph, we have a half a wave here, one full wave, and then like the kind of matching half with the beginning. Okay, it's kind of like the kind of tail and the head there. So you actually have 2 times that the graph repeats itself within that range of 360 degrees. So the period of the tan x graph is 360 divided by 2. It's actually 180 degrees. That's how many, that's, you know, how many degrees it takes for the graph to complete itself, okay? So, things to note at the bottom of your notes there, if we have the graph of y equals minus sine x, or minus cosine x, or minus tan x, that minus 1 basically in front of the trig function, all it does is it starts in the same place, finishes in the same place, but it just goes in the exact opposite direction. So it goes down first, then up, rather than in our original one, it went up, then down. And it's the same for the cosine, same for the tan. So what we need to just quickly be able to do now is identify the amplitude and the period. So the amplitude, this time not from the graph, but just from the equation, it's really, really simple. The amplitude is just whatever the number is in front of the trig graph. The period is just 360 divided by that number. Okay? So if you have a 1 sine x, the amplitude is 1. Okay? If you have sine 2x, that means the graph repeats itself twice. So the period is 360 divided by 2, which is 180 degrees. So there would be 2 full waves in 360 degrees. If it's 2 cosine 4x, the amplitude, that means it goes up to 2, down to minus 2. That's a distance of 4. The amplitude is half of that, so therefore the amplitude is 2. So it's just the same as whatever number is in front of that trig graph, trig function. This is a 4x this time, which means that there'll be 4 times the many waves in 360. So 360 divided by 4 means that that graph will repeat itself every 90 degrees this time. And we should be able to kind of do the same for the rest of these yourself. So just whatever number's in front of the trig function is your amplitude, and it's 360 divided by that number in front of x. That's going to be your period. Okay, so we might as well just quickly finish these off. So y equals 3 tan 3x. The amplitude is the number in front of the trig function. So the amplitude is 3, means it would go up to 3. Oh, sorry, no it doesn't, because it's a tangent graph, so there is no amplitude. Caught myself out there. The period is this time dealing with tan, which is always a little bit different. The original tan x, remember, had a period of 180. So if we have tan of 3x, it's actually 180 divided by 3 for the period in this case. So 60 degrees. It would repeat itself every 60 degrees. Okay, back to sine in the next one. 10 sine a half x means an amplitude of 10. A half x means 360 divided by a half, which is the same as 360 times 2, so it's actually 720. So actually there's only half a wave within 360. Minus 4 cos a quarter x, amplitude is minus 4, means it would go down first, and if you were drawing it out. And the period of this graph would be 360 divided by a quarter, similarly to the last one. That's the same as 360 times by 4, or 720 times by 2. So the graph would, one full wave would be every 1440 degrees. So there's only a quarter of a wave in 360. And the last one, it's a tan function, so there's no amplitude, and tan x, the period is 180, so tan 4x is 180 divided by 4, so 45 degrees. Okay, so last thing we're doing is, just to set you off before you do your questions for yourself, is example number 2, which is identifying the equations from the graph, right? And then you're going to do some questions after this. So we're only dealing with sine x and cosine x. We're not dealing with tan initially. So look, basically all you have to do is, first and foremost, you look at the graph. So if we look at example A, we look at the graph and we think, right, Is it sine or cosine? That's number one. Now, it's starting at 0 and it's in an S shape, which means it is the sine graph. So it's definitely sine, and we can mark that on. It's definitely sine. What is the two things we need are the values of A and B. Now, A being the amplitude, half the distance between the maximum and min, and B being the number of waves in 360 degrees. So in this graph, if I draw these angles here, these two lines here, we can see the maximum is 3, the minimum is -3. That's a distance of 6. Half of that distance is 3. So it's the graph of 3 sine. How many waves are there in 360? There's one max and there's one min, and it goes back to the start. So there's just one wave. So it's 1x, which we can just write as 3 sine x. If I do the next one, it's starting at its maximum, coming down to the bottom, then returning to its maximum, which means that is a cosine graph. What is the distance between the maximum and min? That's the first thing, next thing you look at. Well, that's up at 5 and going down to -5. That's a distance of 10. Half of that is just 5. So it's 5 cosine, and again, there's only one wave in 360, so it's 5 cosine x. Okay. The last one in this row is, again, a sine graph because we're starting at 0. Although it's not going up first, it's going down first, which suggests this must be a negative sine graph. But it is definitely a sine graph, but it is going to be a negative sine graph, a negative number in front of the trig function. Now it's going up to 2, down to -2. It's a distance of 4. So half of that is 2, so it has to be a -2 sine, and again there's only one full wave, so it's -2 sine x. Okay, so we're going to stop the notes there, and you're going to try some questions for yourself now. Okay, so first one is Unit 3 booklet, if you can get those out. It's page 27, and it's questions 1 to 3. So this is just going to be 3 questions, just drawing your own version of the sine graph, the cosine graph, the tan graph, using, as you can see here, using quite a lot more angles to give you a kind of more accurate curve. So I just want you all to do this now, just to give you another experience of what those 3 individual curves look like. So you're going to do that first, and then you're just going to go to the next page, page 28, and I've just taken a screenshot of the first 6 questions, but I want you to do the full of question 1. So you look carefully at where the graphs are. It's only sine and cosine, so same as the example we just did in the notes. Look at what the amplitude is, the distance between the maximum and the minimum, and then how many waves are there in 360. That's going to be, I think actually they are all just a 1x, so it's just looking at the amplitude there. Okay, so I just want you to do question 1. If you do feel that you're comfortable enough, trying question 2 as an extension. If you've got time, you can try this as well. So I say, and question 2, if done. Okay, hopefully get on with that all right, and I'll have another video up for you tomorrow, or hopefully I might be in work tomorrow to teach you the lesson. Cheers guys, thanks.